This video will guide you through the process of adding and running 7 SDR receivers on a single computer using SDRDuo with SDRDuo. Before proceeding, ensure that your SDRDuo is not running, as certain settings may not be accessible or could be restricted if the software is active. On the main window, locate the ADRX button and click it 6 times to incorporate 6 additional receivers. This action is necessary as we already have one receiver open. To activate a new software-defined radio, click the red button next to the respective SDR. Once clicked, the designated SDR transitions to an active state. Subsequently, press the RX button to initiate the SDR receiver. Let's initiate the process by activating all SDRS receivers and arranging them in a systematic lineup for efficient management. In the meantime, on your right screen, I have the system settings open, allowing you to monitor how my system operates at any given moment. Receivers are now active. Let's proceed by customizing the settings for each individual receiver, starting with the main one. This is how we will configure the audio outputs for every SDR receiver. It's important to note that you will require more than one audio output to ensure proper audio reception. I experimented with running all receivers on a single audio output, resulting in completely unintelligible audio when 2 or more receivers were receiving simultaneously. On my computer, there are 4 available audio outputs. Let's assign a specific audio output for each receiver. As you can observe, the first 2 receivers are utilizing the audio box as their audio output. One is connected to the virtual cable output, while the other 2 are using the NVIDIA audio output. Lastly, the remaining 2 receivers are connected to the digital audio output. Let's initiate the test or configuration process by clicking the play button on the main SDRDuo interface. Confirm that everything is functioning properly. Once verified, proceed to the next step by closing all configuration windows. Utilizing the workspace feature in SDRDuo provides you with the convenience of avoiding repetitive settings adjustments. By saving your SDR positions in the workspace, you eliminate the need to redo all the steps when using multiple receivers in the future. To save your workspace configuration, simply press Save WS in the main Windows menu, which displays available slots. In my scenario, I'll use Workspace 2 and label it 7RX. Click the Save button to store your configuration effortlessly. The next step, making fine adjustments for optimal general usage. Press the OPT button in the main panel. By default, SDRDuo operates using a normal process priority. However, since we are running 7 receivers simultaneously, it is advisable to enhance the working process for smoother operation. Change the process priority to high for improved performance. The next step is to set the SR frequency for the spectrum bandwidth of the waterfall display. It is essential to configure this to a 10 MHz bandwidth for all 7 receivers to capture the entire spectrum effectively. In the SR megahertz spectrum bandwidth, there is a fixed DEC that cannot be changed, as we are already utilizing the full 10 MHz bandwidth. Next, select your antenna input. Navigate to the IF mode settings. Within the IF mode settings, you will encounter 2 options, Z if and L if, and selected Z if mode due to its 10 MHz bandwidth. However, it's essential to note that switching to L if mode will automatically reduce your display bandwidth to 2 MHz. Next, let's make some additional adjustments. On the main window, press the Set button and ensure that your settings match mine. USB transfer mode should be set to isochronous. Input level must be configured to display gain. If mode should be set to 0 if. Next, navigating to the next submenu located at the top, specifically for automatic gain control, a GC. By default, the AGC is enabled. To make adjustments manually for a GC, you need to disable it by unchecking the AGC option. This is particularly useful when working with high-frequency bandwidths, requiring precise adjustments for optimal performance. The next step is to test all SDR receivers. Simply press play in the main window, and everything should function properly. You'll notice increased activity in the system at the left corner of the MAIN window. This is normal as more receivers are now active. Let's examine the overall hardware performance of my computer. I've observed that my processor is reaching nearly a 100% usage, but this doesn't seem to be causing any issues. On the other hand, the GPU is operating at a lower usage level. Next, let's open and add 7 main spectrum plots or waterfalls for each software-defined radio by pressing the SP1 button. Adjust the size and length of each one accordingly. In my case, I'll place all the main SP plots under the SDR receivers. The initial adjustment and resizing may take some time. Therefore, it's crucial to save your workspace once all resizing and positioning are completed. This way, you won't need to repeat these steps. Now that all waterfalls are in position, let's assess my CPU once again. This time, it's consistently running at 100% utilization. Surprisingly, my memory usage is at a mere 21%, while the GPU is idling at 8%. Interestingly, this doesn't concern me, as the system operates seamlessly under optimal conditions, thanks to the efficient functioning of L1, L2, and L3 cache banks, which efficiently handle a multitude of tasks. Let's focus on the primary receiver, denoted as SDRDuo. When the main frequency is adjusted, it prompts all other SDRs to shift their respective frequency ranges accordingly. This is a standard behavior due to our 10 MHz bandwidth. For instance, if we center or mark the receiver at 248 MHz, there will be a margin of 5 MHz below and 5 MHz above. This adds up to a total bandwidth of 10 MHz. Now, let's explore some quality signals to fine-tune our settings in the final stage. We will make precise adjustments, akin to a waterfall zoom, ensuring the center waterfall is optimized. Additionally, I'll highlight a bug I discovered in the SDRDuo software. Pay careful attention. When adjusting the frequency in small increments, the subsequent receiver tends to lose its marker or completely disregards the change. To rectify this issue, simply press the VFO to restore it to the initial position. Once all receivers are set up at the correct frequency, manual adjustment of the automatic gain control, a GC, is necessary to prevent overload issues. We opt for manual mode due to its ease of control. Navigate to the Settings button located at the top left corner, press it, and proceed to adjust your GC settings. We have configured all 7 receivers to operate at distinct frequencies, and they are now prepared to receive both analog and digital signals. By the way, if you choose to monitor DMR radio frequencies, consider reducing your audio outputs to 2. Give it a try and see if it works. Let's assess the current status of my computer. The CPU is operating at full capacity 100%. The GPU is holding steady at 9%, and the memory usage is hovering around 5 gigabytes. Everything is functioning smoothly with no noticeable lags or audio overload. Let's review the key settings once again. Please ensure you carefully check them and make a note of any details you might have missed. Hope you enjoyed the video. Subscribe now to stay updated and catch our upcoming content. Thank you for watching.